Hi, everyone. We're back, and I was always wondering how do you know if we add something to something else, will it react? And if it reacts, see some fizzing going on here. How do we know what products are going to form? Good questions. So today, we're going to start talking about reactions, types of reactions. That's chapter 11 in our online text. So let's start off with looking at some reactions. So let's consider this first chemical equation here. What do we have? Silver nitrate in aqueous solution reacts with potassium chloride in that aqueous solution to give us or yield potassium nitrate and silver chloride, which is a solid. So what do you expect to observe if you carry out this reaction? Well, according to this equation, we can see that we're going to start with silver nitrate, but we're not going to end with it. We're going to end with silver chloride. We're going to start with potassium chloride, but we're not going to end with it. We're going to end with potassium nitrate. And what we're going to see is that a solid appears out of a solution. Here we have aqueous, which means dissolved. Here we have aqueous, which means dissolved. We're going to react two aqueous solutions together, and presto, a solid will appear. That is called a precipitate. A solid appearing out of solution is called a precipitate. So that's what we're going to see by looking at this reaction. Now, if we just had the silver nitrate and the potassium chloride, would we be able to predict what the products would be? So let's look at chemical reactions. Do you think that there are types of chemical reactions? That chemical reactions take place in similar sort of ways? If so, would you be able to predict the products of these reactions? Well, we already know about neutralization reactions. We saw that with acids and bases. A neutralization reaction is when an acid reacts with a base and forms water and a salt, or salt and a water. Here's an example. Hydrogen chloride or hydrochloric acid reacting with sodium hydroxide gives us H2O and sodium chloride. Sodium chloride is table salt. Here's another example. Nitric acid, HNO3, reacting with KOH, potassium hydroxide, gives us water and potassium nitrate. Metal, non-metal, this is also a salt. Let's look at another one. Carbonic acid, H2CO3, plus calcium hydroxide is going to give us water again and calcium carbonate. Calcium's metal, carbonate, non-metal radical. So metal, non-metal, salt, metal, non-metal is a salt, metal, non-metal is a salt. Acids plus bases gives us water and a salt every time. And that's called a neutralization reaction. They cancel each other out. So what are some other types of basic chemical reactions? So let's take a look at a basic one. First, basic chemical reaction. Here's our, from just before, our carbonic acid plus calcium hydroxide giving us water and calcium carbonate. Notice the calcium carbonate is solid. Well, when we look at a chemical equation, everything on the left side of the arrow has a special name. We call these the reactants because they're reacting, and what's formed or what's produced on the right are called the products. So the reactants on the left, products on the right. And when we read these, we interpret this plus sign not to mean carbonic acid plus calcium hydroxide, which it pretty much is. We would say carbonic acid reacts with calcium hydroxide. The arrow is not an equal sign. It's what we call a yields or produces. So carbonic acid reacts with calcium hydroxide to yield water and this plus is and because we're not reacting here, this is a product, calcium carbonate. And of course, the S is indicating solid. A solid that appears out of a solution is called a precipitate. And those are our basic rules for chemical reactions. So, chemical equations allow chemists to predict and track changes in matter. They indicate how many products are formed and what those products are and the phase of each product. Observations of chemical procedures provide information not covered by a chemical equation and vice versa. And observations alone cannot tell you what substances are present. You need that chemical equation to see what happened. When I showed that fizzing in the beginning, we saw gas being released, but we don't know what those reactants were or what was produced in that beaker. Let's check in. How would you interpret that? I'll give you a minute. Okay. Let's see if we came up with the same interpretation. Calcium chloride dissolved in water reacts with sodium hydroxide dissolved in water to yield calcium hydroxide as a solid or a precipitate and sodium chloride dissolved in water, aqueous. Notice the 2 and the 2. What is that telling us? Well, it's telling us we need 2 sodium hydroxides for every 1 calcium chloride to make this reaction proceed correctly. So this reaction is going to use up twice as many molecules of sodium hydroxide for every 1 molecule of calcium chloride. So there are 4 basic reaction types: combination, decomposition, single exchange, and double exchange. Combination reactions are when things combine. So if I have substance A and substance B reacting together and I get 1 product, that's a combination reaction. Decomposition is the opposite. I start with 1 substance, AB, and it breaks apart, decomposes to form A plus B, substance A plus substance B. They break apart. Single exchange reaction is when you have A by itself, and then it reacts with BC, and what is produced is a new substance that is a combination of A and C, and B is liberated or set out free on its own. Double exchange takes that 1 step further. A plus B and C and D together basically swap. And so A is now with D, and C is now with B. So we have multiple types. We have 4 basic types of reactions that we're learning now. And sometimes I think it's easier to understand what's going on if we think about things in human terms, because there's a lot of similarities between the way people behave and the way chemicals behave. And we often say that there's chemistry between people. Well, it's a lot more complicated than that appears at first. So I'm going to try to talk about how these chemicals react in humanistic terms to try to help us remember how these things work. So combination reaction, several reactants combine to form a single product. Combination reactions are easy to spot because there's only 1 compound on the product side. As a general rule, the reaction can be written like that. A plus B yields AB. I call this the get-together reaction, where these 2 things get together and form something new. Decomposition is when a compound breaks down as a result of chemical change. Decomposition reactions are easy to spot because there's only 1 reactant. They're starting off together and they end up apart. I call this the divorce reaction. You can think of it as breaking up. So they were together, not anymore. Single exchange? Well, single exchange is when a compound breaks apart and 1 part combines with the other reactant. And it could be an atom or it could be radical or polyatomic ion like hydroxide or carbonate or nitrate. So typically, one of the reactants is an element, and generally we write this down as A plus BC yields AC plus B, where A displaces B. So A's, think of it like this. B, C, and C are together, right? They're like walking down the street, and here comes A. And C says, wait a minute, B, you might be nice and all, but A, I like a little better. So bye-bye, B. Hello, A. I call this the I've met someone else type of reaction. The single exchange or the single replacement, where one of them is replaced by something else. And double exchange is when both reactants break apart. Their parts then recombine into two new products. Thus, the two reactants exchange parts. In general, the reaction can be written like AB plus CD yields AD plus CB, where B and D exchange with each other, or A and C exchange with each other. Hey, do you guys ever remember that old TV show? You probably don't remember it, called Wife Swap. Wife Swap was when you had two families and they would exchange the one mothers. And of course, what would happen is they would, um, you know, spend time with the other family, say, these people are nuts. And they'd run home and they're like, ah. So say A is a metal, it's with non-metal B. Now A is with non-metal D. Meanwhile, C was, which was with non-metal D, C is now with B. So they swapped partners, and we have two new substances. So that's a double exchange reaction. I like to, I can think of these, I can remember these. So let's check in. Bromine, even though it's Br2, is one substance. Here we've got sodium chloride. Well, sodium's one element, chlorine's another. This is a compound. And what do we have here? Sodium is now with the bromine, and chlorine is off by itself. Oh, what do we call this? Single exchange. This is calcium carbonate. And what happens is it produces calcium oxide plus carbon dioxide, two substances from the one. You have one reactant, more than one product. This is simply decomposition. Here you've got silver iodide and strontium bromide. Here you've got the silver now with the bromide, silver bromide, and the strontium, well, that's with the iodine. Oh, they swapped partners. This is a double exchange. And here we've got carbon dioxide plus sodium hydroxide to form sodium bicarbonate. Hey, there's only one product. These things come together to form one thing. They're combining. This is either a combination or synthesis reaction. All right. So let's try some examples. What I'd like you to do is try to predict these and pause. Write them down on a piece of paper so it's, for sure that you have actually predicted it. And then resume the video and see how you did. So let's start with the first one. Sodium hydroxide plus nitric acid dissolved in water is going to give us sodium nitrate and water. What kind of reaction is this? If you said double replacement, you're right. It's C2H4 and Cl2. Now we've got one product, C2H4Cl2. This type of reaction is okay. Synthesis or combination. You can use either word. This one, chlorine, magnesium bromide, gives us bromine and magnesium chloride. This is single exchange. Nitrogen plus hydrogen gives us N2H4. This is, so it's dinitrogen tetrahydride. Synthesis or combination. Potassium nitrate and potassium gives us potassium oxide plus nitrogen. Single replacement. Sulfuric acid plus sodium cyanide is going to give us hydrogen cyanide plus sodium sulfate. This is double exchange. Phosphoric acid plus calcium hydroxide yields calcium phosphate and water. This is double replacement or double exchange. Either one is acceptable. Now we've got sugar, C6H12O6, that's glucose, yielding carbon dioxide and water. This is an example of decomposition. And here's H2S, hydrogen sulfide, plus oxygen as a gas, giving us sulfur dioxide gas, very stinky, and H2O, water. This must be double replacement reaction. This one is tough because you have O2, but what's happening is one oxygen is going here and the other oxygen is going there. The hydrogen is going here, the sulfur is going there. So this one is really tricky, but especially because there's two oxygens and because, hey, there's 1, 2, 3 oxygens on this side and only 2 on this side. There's something wrong with that. And I think we've got an idea of how we might fix it. It's called balancing the equations. We'll get to that. What are the 4 types of reactions we learned? That's combination. What about this one? Decomposition. There's only got one reactant and multiple products. This one, single exchange. And this one, you got it. Okay, there you have it. So start on your book on chapter 11 on page 344 and try to identify on these worksheets the 4 types of reactions. Good luck.